Okay. So what we're going to look at today is something called implicit derivatives. So far we have product, quotient, chain rule. Now we're going to look at a new type of problem. So let me give you an example of it. So you have, for example, x plus y equals 1. And I ask you for dy dx. Not too difficult here because all you have to do is rewrite it. Y equals 1 minus x. So dy dx equals minus 1. And that's fine. But what happens if it was something like this? Now this is an entirely different problem because now we cannot easily get the y out from this. It's not possible actually to get the y out. The y is stuck with the x. Can't be separated. So if I ask you for dy dx, it might seem impossible now because you have no way of getting the y out. But in fact it's not impossible. So before we look at this example, a small little result here. If I have a function of y, so for example y squared, y cubed, sine y, cos y, whatever, you can't really calculate the derivative of it because the derivative is what variable? Well, usually x, right? So what can we do? Well, what we can do is write this problem now like this. Now, are these two things the same? Well, they are because this could cancel this, leaving you with the same thing, right? But there's a big difference here now because what's this letter here? dy. So we can treat y as if it was like the variable. So then we get this result. F derivative y. So in other words, after all of that, my point I'm making is if you have something with y in it and you want to calculate its derivative, do it normally, but multiply the answer by dy dx. So for example, if I want the derivative of y to the power of 10, that is 10y9, but as we saw in this little proof here, you have to multiply by dy dx. So that's the key idea for this lesson. Whenever you differentiate y, you multiply your answer by dy dx. So I'll say that again. Whenever you differentiate a function of y, do it normally and then multiply the answer by dy dx. Okay, so make notes there. That's important. So this is like the rule if you want, and this is an example. So here is me calculating the derivative of y to the power of 10. It doesn't really have a rule name. It's called implicit differentiation or implicit derivative, but it's still just derivative. Yeah.
Could we, instead of dy dx, write y prime?
Absolutely, yeah. If you want to, that's perfectly fine. You could write this as 10y9 y prime.
Sir?
Yeah.
Can you repeat what you said whenever you differentiate?
Oh, but I said it twice. All right, third time. So whenever you differentiate a function of y, you do it like normal, but multiply the answer by dy dx. Okay. Once you have this written down, we'll look at some real examples now. Well, actually, yeah, we'll look at some examples. Can I do one now? Yes. Mohammed? Yeah. Oh, who's replacing Ahmed Habib? Because I need one student to look at to know when everybody's finished writing. So after Ahmed Habib, who was the second slowest to write? Anybody? Anyone want to volunteer? No? Hey, you're not that slow to write, Joseph. Alright, I'll keep an eye out for it. See who's the second slowest writing down. Okay, so here's our example. X squared plus y squared equals 1. So we differentiate everything. Derivative of x squared, 2x. And here's the difference. Derivative of y squared, 2y dy dx. And derivative of 1, 0. Now, this can be cleaned up. 2y dy dx equals minus 2x. Take the 2x over. And then divide by 2y. And then cancel the 2's. So you have dy over dx equals minus x over y. And that's the answer. But there's something a little bit unusual about this answer. Anyone see what's unusual about the answer? Yeah, what's that? Yeah. What's a bit strange here is that y is in the answer, just like with x. And in fact, this is the price you pay for doing implicit differentiation. That your answer has x and y in it. Which is reasonable because the question had x and y in it and they couldn't be separated. Okay, another example? We'll make one a bit more difficult now. Let's have a look here. Yes. Okay. Another example. Do you need more time? Are you sure? All right. Yeah. Okay. X squared plus xy plus y squared equals 1. So this was my original question at the start of the lesson. Let's try our new technique on this. So x squared becomes 2x. So that's done. And what does xy become? Yeah, well, let's be very careful here, okay? Listen, be very careful. If you think about it, this is a product, x times y. They're being multiplied, aren't they? So you need the product rule. So first derivative of x, which is 1, and you keep y the same. And then keep x the same, and derivative of y is 1 dy dx. Plus 2y, come on, 2y dy dx equals 0. Okay, so let's clean this up a little bit. 2x plus y plus bracket x plus 2y dy over dx equals 0. So I just take the dy dx out from both here. Then you have dy dx with the bracket here, x plus 2y, equal to minus 2x minus y. I take these over to the right. And then to finish, what do? I divide by this. So let me add a little bit to the question. So that can be part 1. And then how about now part 2? Let me think about this. I'm just going to change this. It doesn't change any of my work here because the derivative of a constant is 0. But just in the original question, could you change this to 3, please? Okay. That was part 1. Part 2 is find dy dx when x equals 1. So what would I normally do? Substitute in. If I put x equals 1 into this, am I finished? No, what's the problem? Yeah. So how can I find the y?
Substituting the first.
Yeah, I could put x equals 1 into this, and this could give me the y. So if I put x equals 1 into that, I'd get 1 squared plus 1 times y plus y squared equals 3. Or, in other words, y squared plus y minus 2 equals 0. We haven't seen this in a while, have we? Quadratic. Y plus 2, y minus 1. So in fact you get two answers to consider. 1 or minus 2. So actually you have two possible answers here. 1 or minus 2. So, oops. What's happened? Zoomed. Uh-oh, I don't like the look of this. There we go. Now, that means we actually have to consider this possibility, 1 and 1, or 1 and minus 2. So if you take out your calculator, students on this side of the room, please put x as 1 and y is minus 2, and then students on that side of the room, put x as 1 and y is 1. So you got dy dx when you're at 1, 1, what does it equal? Minus 1. And then the other possibility,
0.
dy dx when it's 1 and minus 2 equals 0, yeah. I'm hearing, guys, you're making this side of the room look bad. Would you just put the numbers in on your calculator and hit the magic buttons?
It's 0.
Is it 0? Is this agreed? Okay. Does anybody know why there's two answers here? Like I said x is 1, but I got two possible slopes. How did that happen? Any ideas? Yeah, it's what, but what way would the parabola be? Yeah. Square. Oh, you're way off. Not square.
Yeah, like one this way, the other one this way.
Yeah, but what shape, what curve could it be? So it will look something like this. The curve must have been something like an ellipse or a circle or an oval. So here's the x-axis. So when x is equal to 1, you have actually 2 points on the curve. This was y equals 1, and then this one here is y equals minus 2. And then you have two different slopes. Now I know it's not a circle because the slopes are different. Like if it was a circle, I think, you know, if one slope is 3 over 4, then the other slope would be if negative 4 over 3 or something similar to it. But in this one here, the one down the bottom has no slope and the one at the top is negative 1. So it's kind of some weird squished circle. You don't actually need to know the graph for the exam, but I just want you to know the reason why you could get two answers. And the reason you could get two answers is because the curve doesn't go like this normally. Instead, it's looped back around. So you could have a slope at the top and a slope down the bottom. Now in the exam, they'll never ask you to draw this, but they might give you the graph in the question. So don't be surprised if you see something like this. Okay? So write that down, please. Just draw some kind of oval to show the two shapes on it. I'll try and draw it a bit better, actually. So let's see. I think it'll be kind of more like this. Because with a shape that's leaning to the right, you can see the slope here is 0. It's kind of flat, yeah? And then the slope here you can see is -1. So if you draw an egg shape but leaning to the right, it would get the result. Now, let me add to this a little bit. Suppose I ask you now part 3 of the question. So if I call this point here A and this point here B, I ask you for the tangent at A. So come on, who remembers this? What do you do for equation of a tangent line? Start off with what? Y equals mx plus c. And what's the m? Slope of what? Yeah, like what? In this case, what is it? Oh yeah, no, actually I should say this. The m is the first derivative, and that reminds me, this was something a lot of people forgot in the exam as well. So when you're drawing a tangent line, its derivative makes the slope here. A lot of people forgot that in question 6 in the exam. So what is the value of dy dx? Which one do I need? It's this one here, yeah? That's A and that's B. So -1. Now how do you find C? You use a point. What point do you use? 1, 1. So you get 1 equals -1 plus C. And yes, we can definitely do this, can't we? 1 plus 1, 2. So there you go, there's the tangent. Y equals -x plus 2. Yeah? -1 and 0. That? But you got that from me. I asked you to put 1, 1 into the formula for dy dx. Now I hope you did it right on that side of the room. That side put 1, 1 in and got -1, and then this side put 1 minus 2 in and got 0. Is it still correct? It hasn't changed?
Okay, so -2 is 0, so it's going to be 0. Like, it's obvious.
No, we're talking about just the 1, 1 first.
Okay.
So 1, 1 is -3 over 3, which is -1. Good. And then 1 minus 2. So -2 plus 2, isn't it? Yes, so 0. Good. Yes. Fate restored. Okay. Did you write this one down? Yes? Okay, let's have a look now. Oh, yes, something else here. Right, yes, this is important now. So, implicit derivatives can be very useful for calculating new rules, such as, for example, what is the derivative of sine inverse x? Now, I'll leave that one for you to do as a homework, but just to give you a hint to start it, let me show you a different example. So suppose I said y equals 2x. You actually, surprisingly, don't have a rule to calculate the derivative here. Why not? Well, because what is the rule that you do have? What's the closest rule that you have? E to the power of x. And here is 2 to the power of x. So you actually don't have a rule for this. So we don't really want the 2 here. So how can I clean this up? What's a good way to kind of clean things up with powers and bases? Well, you can put a log on both sides. So you get log y equals log 2x. And what happens to the x? Comes down. So now I have log y equals x log 2. Can you calculate the derivative of this?
Yes.
Yeah, so what's the derivative of log y? 1 over y dy dx. And what's the derivative of x log 2? No, just log 2. Because think about it, it's exactly the same as like 5x, 6x. It's just a constant times x. So like what's the derivative of 5x? 5. 6x, 6. Log 2x? Just the log 2. It's just a constant. Now, what should I do next? Well, I should bring the y up. And I get y log 2. But actually, you know what the y is. What is y? Yeah, 2x log 2. So the derivative of 2x is 2x log 2. So actually, you have a new rule. If y equals ax, what do you think the derivative is? It's ax log a. And what happens if a is actually equal to e? What's log e? 1. So you would get ex, which we already know. I see, I was hoping for more of a reaction. I didn't get it. Thanks, Abinove. Throw your teacher a bone, huh? All right. Well, the most important thing is that you understand that. So write that down. That was the question, y equals 2x.
I don't understand the last two steps.
In the black or the red? Okay. So tell me, are you happy going from here to here or not?
I don't understand. How did you move the y to the other side?
Oh, I just multiply both sides by y. So, like a y here and a y here. Yeah? And then, how did I go from here to here?
Yeah.
I know what y is from the original question. Y is 2x. So I just replace it with 2x. So, there it is there. I'll do another example of this one. Or do you want one or not? I don't know. Yes? Okay. Right. So now, another example. Watch carefully, please. Y equals, let's say, 2 to the power of 2x plus 1. So we log both sides. Log y equals log 2 to the 2x plus 1. The power can come down. So I can take the power down. Now let's differentiate. So derivative of log y, 1 over y, dy dx, I'll just write y prime, equals log 2. So if you want, you could use the product rule here. First I differentiate log 2. What's the derivative of log 2?
0.
Thank you. 0. Because it's a constant. Yes. And then keep this the same. Plus, keep this the same. And then derivative of this? 2. Now what do I do next? Multiply both sides by y. So I get, sorry, that's getting a bit messy. There's the log 2. Y log 2 multiply 2. But what does y equal? 2 to the power of 2x plus 1 times log 2 times 2. Now, notice that I have 2 of these 2's here. So what happens to the powers? They add. So I get log 2 times 2 to the 2x plus 2. And that's the answer then. Okay, write that one down, please.
What is the 2?
Not really. Like, how else could you simplify it?
Isn't that like x?
You could take it. Yeah, you could take a 2 out and make it a square, but it's not really making it simpler.
Yeah, what is 2 prime?
No, that's 2 power 1. Yep. Oh, what's that? Yep. I used the product rule. So it's like this. Whoops. Fg. So f derivative is 0, and then forget it, plus then this and this one. Huh? Say again, Sayun? I don't know if you're happy or unhappy. Your question? No, I guess not. Okay.
So
Yes?
why do you pick the 2, say, and
The third line. There's a lot of confusion here with the third line. I don't know. Here, let me show you. I'll go back to this, but let me show you on a separate page, okay? Here. On the third line, I have log 2. Please, everybody, look carefully. Log 2 times 2x plus 1. So I'll use the product rule. What's the derivative of log 2? 0. And then keep log 2 the same. And then what's the derivative of 2x plus 1? 2. Yeah? So in my answer, I just wrote 0 for all of that.
Oh.
Yeah? Yeah.
How can you go down this?
Well, you need to write this down.
Yes.
All right. Hang on a second now.